I wanted to just make a quick video about this item in your homework. This is in section 6.3, number 8, and it refers to the discrete model. We have continuous and discrete quantities and models. I'll show examples of each of those and just use part A here as an example for this one. So suppose we wanted to show that 4/5 equals 8/10 using a continuous model. I'm using the area of a rectangle here as one continuous model. Continuous is anything that you're measuring. And if you're drawing a picture, length and area work really well for that. In general, continuous quantity is anything that you measure. So it could be weight, it could be lengths of time, it could be volume, it could be all sorts of things. But often with fractions, we're using number lines or rectangular area or circular area as continuous models. So to show fraction equivalence with a continuous model is pretty easy. Say we have our picture of 4/5. We wanted to show 4/5. Well, standard part whole picture. Here's the whole. We sliced into 5 equal pieces, shaded 4 of those pieces. That's a picture of 4/5. If I want to show that that same amount is also 8/10 of the whole, I could just slice in half. I've doubled the number of pieces, equal size pieces that the whole is sliced into. That makes the pieces half the size that they were before. Now we have 10 of them. And so this becomes a picture of 8/10. So the same whole, same amount shaded. From this perspective, it's 4/5. From this perspective, it's 8/10, but really nothing has changed. It's the same amount the whole time. Now, suppose we want to do the same thing with a discrete model. We want to show that 4/5 is equivalent to 8/10. So discrete model, now instead of measuring, you're counting. So this could be all sorts of things. Anything that you would count, where you think about separate objects that you count, like when you count on your fingers. So you could count the people in the room, you could count the number of pieces of furniture, you could count, in this case we're going to count popsicle sticks, but literally anything that you could count would be regarded as a discrete model. And when you're using a discrete model, you're not thinking in terms of measurement. So it's not just that you're counting, it's that, for example, if you're counting people in a room, those people may be different sizes, but each one counts as one person. So it's a pretty different idea. We're just saying, okay, you're one person, then there's 2, there's 3, there's 4, there's, let's say, 5 people in the room. We're not thinking about how tall the people are or how much they weigh or anything like that. We're just saying that each thing counts as one. And in this case, they're saying to use popsicle sticks as the context. And then in these different exercises, you have marbles, you have children, and you can choose your own discrete context for part D. So anything that you're counting rather than measuring. So if we want to show 4/5 equals 8/10, you might think, well, let's start out the same way. Let's start with 5 of something. This is my attempt at drawing popsicle sticks. And maybe there's something special about 4 of those popsicle sticks. So I'm going to make whatever. I'm going to make 4 of them red instead of brown. So this is a discrete picture of 4/5. There are 5 separate things, and 4 of them have this characteristic in common. But this isn't going to work very well in a discrete context to show 8/10 because I only have 5 of something. I don't have 10 of something, so how am I going to show 8/10 in a discrete sense? You might say you could cut the popsicle sticks in half. Yeah, you could, but remember, we're thinking about discrete quantities, and we're going to do this with any discrete model. So with marbles, we're not really going to cut marbles in half. We're certainly not going to cut children in half. We're thinking about whole items, whole objects here. So cutting in half really goes against the grain of using a discrete model. So with 5 items, you really can't show 8/10 in a discrete sense. you're going to need 10 items in order to do that. So looking at these fractions, 10 is the minimum number of things that we're going to need if we want to show 8/10 of something in a discrete sense. So we might start there instead. Now we clearly have a picture of 8/10, right? Why is it 8/10? Because 8 of the 10 sticks are, let's call it pink, right? Clearly this is a picture of 8/10 because 8 of the 10 popsicle sticks are pink. But is it a picture of 4/5? If it's a picture of 4/5, we need to be able to make a statement like this to say how it's a picture of 4/5 in a discrete sense. And I think that we can, but it might help if we think about pairing up these popsicle sticks. So I put them together like this. You could circle them, you could do different things. But now I'm thinking about pairs of popsicle sticks. And there are 5 such pairs, and 4 of those are the pink pairs. So now I can say I have 4 of 5 of something. 4 of the 5 pairs of popsicle sticks are pink. So this is a picture of 8/10 in a discrete sense, 8 of the 10 individual popsicle sticks. And it's a picture of 4/5 in a discrete sense because I'm thinking about 4 of the 5 pairs of popsicle sticks. So in general, if you're going to use a discrete model, you may need to use more items. Rather than doing this thing of starting with a whole, starting with whichever fraction, and then slicing if necessary, you may need to start with a larger number of items and then think about how you can group those items to show the fraction that has the smaller numerator and denominator.